So last year, some friends of ours moved away and left us a large 6-foot black coffin. All we did last year was put a cross on it and some skeletons, but this year I want to transform it into a rising vampire.
So here we are, here's the coffin, taking the rear off of it, and we can take a look inside. So the coffin's empty inside, just a couple of bits of wood to hold some handles. You can see down below there's the guy that I want to put in there inside it. He's a latex mask from Amazon, and currently he's just on a foam head. We've got to try and get him to move up and down inside. So one of the first decisions got to make is what sort of motor to drive the thing with. Now there's a few choices. This is the most basic of motors used in props. It's called an AC synchronous motor. It's used for turning things like cups, where people make decorative cups, or microwave turntables, or other things like that. Well, you see, it's powered off the mains. It's pretty weedy. 4 watts of power this thing takes, and it rotates at just 5 to 6 rotations per minute. So they're okay for lightweight things that don't weigh very much, don't have much resistance against them, because as soon as you get resistance, you need a lot of torque, you need a lot of turning force. Advantages though, they're very small, they're very light, they're easy to build, they have a nice tapped M4 hole in there, so it's very easy to put things on the shaft. The most popular motor for people is this big guy. It's a windscreen wiper motor that you'd get in a car. So put pretty simply, you've got a massive great motor here and then a reduction gearbox inside this piece here. You can then get a connection onto the end of it, put an arm on, bolt it down and control it via these little terminals. You have a slow speed, a fast speed, and you also usually have a switch in here which allows you to wire it up so it will do run, rotation and stop until the switch is toggled, and then it's 1 rotation and stop. Pretty big, pretty beefy, good for moving heavy things, lots and lots of torque, also lots of power. At 12 volts this thing has a stall current of something like 10 amps. That's a lot of power. The other type of motor I've played with is this. This is from a kid's car, like one of the ride-on ones that they sit on. This is actually a pretty reasonable motor. It's an RS550, rated 12 volts. And you can see, you know, there's a gear chain in here to reduce it. It still runs pretty fast, similar sort of speed to the wiper motor. The difficulty with it is it's quite difficult to mount. You know, you've got 2 wings here is basically all you've got, and the whole thing's very wobbly. It's all plastic gears, so unless you're careful, the whole thing can wobble about as it rotates. But that is a possibility. They will also run at much lower voltages, where they'll run at slower speeds, and that is actually true of the wiper motor as well. You can run these things down if you've got a variable voltage drive for them, so you can actually change the speeds, and that's something you can't really do with the AC synchronous motor. Very difficult to do, so you're stuck with whatever it gives you. The also thing to look at here, of course, is price. Very different in prices. You've got the synchronous motor, you buy them in a handful, they're about $4 each at the moment, 2023. If you buy one of these geared motors, you're looking around $9. The wiper motor, you are looking at $25 plus. What I've been trying to do is use the cheaper motors, these little AC synchronous, and actually use some gears to increase the torque. I've done this on my big fella recently, where I did a 2-to-1 ratio to allow him to turn. This one is also a 2-to-1 ratio. There's 15 teeth on this cog, 30 teeth on this one. So you're halving your speed, but you're doubling your torque. All these 3 pieces are 3D printed. You've basically got this one, very hard to turn now at standstill. You've also got on this 3D print an extra little hole here. This allows me to put another lay shaft in here. This cog can go onto that one, and then a different cog with 2 teeth can go on to lower the speed even more and increase the speed even more, and I'll show you that next. Motors, I've connected them both up to power, just going off to the mains. big warning, if you're scared of playing with mains electricity and you don't know what you're doing, please don't play with it. It's not definitely not down to me if you go along and electrocute yourself. So all I've done here is I've wired a standard motor and a double geared motor to the power, just to show you the difference. Put the power on, you see 5 or 6 revolutions per minute for this guy, pretty slow, but look how slow that is, absolutely monstrous. I think it's about 6 times, for my calculation is right, 2 to 1, 3 to 1, 6 to 1. So this is about 1 RPM, I think, and you can see that there aren't going to be that many applications where that's that useful, but there may be the odd one. And it's all made with 3D printed gears. You can see the gear chain there. Basically a small spacer shifts this cog up so we can use it there. So you can use this as a 2 to 1 or a 6 to 1 reduction. All done with standard M4 hardware. There's no bearings or anything fancy like that. You know, it's not going to last forever, but it's a quick way of getting some gearing. So there are a couple of different things we need to do next. The first one is to work out which head to use and how high to mount it. What I do is just put a piece of tape in the middle of the box, just so that we can draw some lines on it. I've got a couple of heads. There's Bill and Ben. If we use Bill, he's the one with a shorter neck. I want him sort of at the lowest, somewhere around the bottom of his neck will be kind of here. At the highest, around about there. The other one's got a much longer neck, so his highest point is actually where the lowest point of the other guy is, and his lowest point would be somewhere around there. Just write a couple of numbers on just so I know which is which. From that, we'll know where to mount the slider. So here's the draw slider that we're going to try and use. I think we're going to try this little head. There's 3 screw holes here. We could mate up to this by screwing through the rear. So on its full extension, it would put the thing about there, and then on its minimum extension is down here. Now we can't really screw it straight to there because you can see it's hitting his face on here. We need it to be sunk back into the box somewhat, so it's far better for us to put this onto a piece of wood and then arrange a frame around it. And to give an idea of where the wood's got to be, here's a piece of white off-cut board, and it needs to be somewhere around there, which is still off the ground by about 4-6 inches, something like that. So let's mount this to a post. So here we are back at the bench. I've marked up some holes already into the back of the head, and then I've drilled 2 very small pilot holes. And then I'm going to use just a couple of short screws. These, I'm not even sure where I got these from, but they look like they will go quite nicely into there. The problem with these draw slides, they're covered in grease, and the grease seems to get everywhere. I'm going to use, put the first screw in, not fully tighten it, going to line up the other one. Okay, just make sure we don't over tighten them. And the head is now on the slider. So First thing I've realized is, depending on which way I put this in the thing, it might be the wrong way around. I want him to face that way in the actual coffin, which means the platform board that it's going on is going to be that way, basically blocking me from what I'm doing. So we're going to just turn that around, I think. Let's try that again, the other way. I wrestle this through. Again, it's not too scientific. Line the two holes up. Put a couple of pilots in. Okay, quick mistake fixed. So now he should be sliding the right way. So the next thing to do is get a piece of wood, bolt it to the wood, and then see how that fits into the box. So I measured up, found a piece of wood. It's a bit wider than I need, but that's good, because what I want to try and do is make a rack and pinion system to move the thing up and down. It's not something I've seen done before, and I think it could be a good solution to using weedy low torque motors to lift things up. So I marked up where I need the thing to go. Just marking the holes. You'll notice I've not put it in the middle because I want to put the rack motor that side. Just drilling a couple of pilots. And a couple of short screws. Need to get that torque limiter off to get them in. Okay, and we're in. And that's parallel to the side. The screws don't stick out the bottom. And now what we notice is the wood was too long, because look, the skull or head can't go all the way down to where I want it to go. So even though I started with a longer piece of wood thinking that would be okay, back to the drawing board, cut the thing down. So quick visit to the saw table just to cut the thing down to size. And this is just to show it's being done live here, because you wouldn't make that mistake if you were making a second one, would you? So second screw going in. First is already in. And now the head goes all the way down to where I need it to go and all the way out again. So here we are, the coffin. The thing stands on the floor and it's fully extended. It's got about 1 inch or so down, which is what I want. And then when his head goes all the way down, you can't see him anymore. So that's pretty much perfect for its distance. So now what we've got to do is find a mechanism to move this up and down, and a method of mounting it. So here we are back at the bench. So the idea is to put a rack along this section of the metal and then have a motor with a long cog leaning out over the top of the rack. As the motor turns, it will move the head out by moving the rack. And what you notice here is because we've had to mount the head on the back of this top piece, then you can't get the full extent of the movement because it goes off the end of the cog. It would spit it off the edge. So either we extend the rack out this far, which will be wobbly when you make it out of plastic, or we simply have to put up with it being not quite so high in the box, and his head either not come out as far or not go in as far, both of which I think are okay for this application. So the next thing we need to do is measure up for the actual rack itself. What I'm going to do now then is mark, that's where the end of this white pole comes to, that's where the end of that rack comes to, and very approximately I can see that there are screw holes to get into the rack at these sort of positions here. Now I'm going to measure them accurately and transfer them over to the CAD system. I'm going to do this in Fusion 360. The first thing I'm going to do is design the rack itself, and then a motor mount and a pinion gear to go with it. Then we're going to 3D print it, put it together and see if it works. Now one thing we should think about already is when the motor turns, it's going to push this head up. Now what's to stop it from keeping going and unmeshing or just hitting there like that? So we're going to have some sort of limit switch that tells the controller or the motor to turn around and go back the other way. So what I'll do on the actual rack itself, I'll put a couple of little nubs on it so that when the thing is moving, the nub's sticking out. When it gets to the top end, it hits a switch which tells it to go back down to the bottom, and then potentially have another switch at the bottom as well. That way we can control the movements up and down. So now I'm going to make some measurements on here and put them into the Fusion program.
Okay, so here we are opening up Fusion. I'm using an insert to insert a gear. I'm going with a DP of 1.25, makes it nice and chunky, and putting in 70 teeth and a couple of basic chunky dimensions. Don't want the thing to be too small or break. Very quick, creates a rack. Just double checking the length of the thing, 220 something millimeters, just the right length. Next thing we need to do is put our mounting holes on the back. So I'm going to open up a sketch on the back face of the thing. Going to zoom in a bit. Going to put a circle. Want to make sure it's in the center. Making sure I find the center point there. If you go down the edge of a sketch object, by default you get a little blue dotted line. Put a thing in, putting in a size I can put a self-tapping screw, and I'm constraining the measurement to match how far I need the piece away, the hole away from the end of the piece. And then there was a second hole, which again is going to give me a little blue line. It's going to go out to the middle. And then just type in the dimension, the hole, and the separation again. So now you've got your two sketch hole positions on the back. Select them both and extrude them to make holes to put screws into. Now I'm not going all the way through because obviously that would mean they would pop out top of the rack, but they're deep enough to get a decent sized screw in the back of. The other thing that might be worth doing is to put some sort of end piece on, just to allow a switch or something like that to go. May not need to do that in the final one, but it isn't really going to cost anything. So I've just drawn a shape on the one face, extruded it out, and then just to give it a little bit of extra strength, just going to chamfer those two edges that meet up. So there's the completed rack. It's got holes on the bottom, a little bit on the side, We're going to pull that through to the 3D printing software. So we export the rack. Here we are into Cura. That's the normal slicer I use for the FDM printer. First thing I'm going to do is just put it on the bed, rotate it around so it will fit, because it is 230 millimeters long. That's in a good location. I'm using a 0.8 millimeter nozzle, which allows me to go down to 0.2 millimeter print or up to 0.4 if I don't need it to look too pretty. I'm going to go 0.2, and I'm also going to set the infill to 50, which should give a nice strong design. Just looking through the rest of the settings. Speed okay, needs to run a bit slower when you're using a bigger nozzle. And supports, we don't need supports. And for this type of thing, we don't really even need any surround, so we're not going to use a skirt or a raft. So there, we're going to just rip it quickly, put it to disk, just have a little look at the layers. You see as we start off from the bottom, it's solid, then it starts to infill. Then you start to get your solids in the top surface. You've got several layers of solid plastic. It should be nice and strong. Save that to disk, and then we're going to load that up into the 3D printer.
So here we are back at the workbench. Here's our 3D printed piece. Came out last night. Nice and clean. You can see the little mounting hole positions here. Hopefully they line up. One line's up there, one line's up there. So we're just going to extend the head out and put the screws in. Okay, so the thing's screwed on. Here you see a rack mounted on the slider. Going to go up and down with the head. So the next thing to do is look at how to mount a motor to turn a cog to move the rack up and down. So as quick proof of concept, took the cog off the geared system I had earlier, wired it up to the switch. You can see it's spinning nice and slow. And if I just manually mesh that with this gear set, you can see that the head is going up as it turns the rack. Pretty slow. Looks like I can't mount the motor exactly on this flat because it's too tall, doesn't mesh with the rack, but I can just rotate this thing on its mount and find, a good point where it will mesh and move the thing. So rather than go fancy and 3D print, I figured I'd just put a couple of wooden blocks there. Supports the motor pretty securely, and you can see when I turn the power onto it, it's doing its job, it's moving it. This is an old cog, it's worn out, it's been used for my testing, but just look what happens now. When it gets to the end, it's got no resistance, it keeps turning and it doesn't know to turn around. So what we have to think about is how to switch the motor around. So this type of motor has a bit of an oddity in that if you actually stop it turning, if I can actually do it, it will turn around and go back the other way. Let's see if I can do it with these. There we go. So all I've done is put torque against the motor and it's swapped over its direction. So we have to basically come up with a solution that either does that electronically or mechanically. You'll see I've added a screw basically here at the bottom. So what happens is this screw stops this second section sliding. Because it's limited, that limits how far the top piece can actually go out. So you'll see as it goes towards the end, you'll see that it reaches its limit, puts some strain on the motor, and then turns it back the other way around. You see? And you'll see this piece slides, this piece goes, and what you get then is towards the end of the travel, you'll see that this black plastic piece will now hit against this exposed screw and turn the thing up the other way. So purely by putting a screw in to the slide in the right place, we actually get it to reverse the motor automatically for us without any extra pieces. So all we need is our rack, our cog on the end of the motor, and we have up-down motion going on. And here we go, it's going to hit the end. Can't go any further, turns the motor round. Very simple. No fancy needs for any extra wiring. No fancy needs for any ratchets. Should be nice and reliable. Okay, so here we are, bolted into the thing, just a couple of bits of wood, secure it in place. You can see it's just dropped below the minimum there. Now it's on its way back up. It's pretty slow. I'm hoping that will look creepy and not just painfully slow when it's installed. You can see the cog has plenty of turning force now from a very basic motor and is lifting that quite happily. Next thing to do is to decorate the head and make sure it looks good from the outside. So it's daylight in here, but you can just see the effect. There he is at his minimum, and then here he rises slow as can be. Maybe I'll put some.
So I decided that was too slow, the motor, so I swapped it out for an 18 RPM motor. And here's just a quick look inside to see what it looks like with a little bit of wiring in, a little bit of a bulb in here just to give some